Okay, today we're going to talk about the least square regression line and how we come up with it. And I put a few points on here. 3 points is the smallest amount of points we can do this with and still be pretty accurate. And so what we want to do here is, first of all, one of the rules is we need to have a point at x bar, y bar. So x bar is equal to 7 and y bar equals 11, so we know that there's going to be a point at 7, 11. Okay, and so when we go through, and the point 7, 11 is right here, and when we do this, and I'm just making a random old line somewhere on this page, the reason why they call it the least square regression line is because we want the squares made by the vertical distance between the line and the points to be as small as possible. So the area of these squares we're going to try to minimize. So y hat in this case, if we go back to the fact that we have, remember, b is the slope, and we have this as an equation of a line in point slope formula where b is the slope, and y hat is the predicted, the y for the line, and x doesn't need a predictor. And so I'm going to say y hat equals y bar plus b times x minus x bar. And then in order to get the equation for the squares, I'm going to make y minus y hat equals y minus all of this stuff over here. So one last thing before we go on, not that it makes a difference, but this is the way they write it on the paper. If I distribute the negative sign, then this becomes x bar minus x. So the only thing we don't have in this little equation is the b. So I'm going to do 7 minus 11 plus b times 3, or I'm sorry, not 3, but 7 minus 3, which is negative 4 plus 4b. And that's the first one. And the second one, we got 12 minus 11 plus b times 7 minus 7, which turns out to be 1. Because the 7 minus 7 turned out to be 0, and 12 minus 11 turned out to be 1. And the last one, we have 14 minus 11 plus b times 7 minus 11, which is 3 minus 4b. Now we're going to square them all, because that's going to give us the area of the square. So when I square this one using FOIL or however method you want to, sorry, that shouldn't be 8, that should be 32b plus 16b squared. The next one, when I square 1, I get 1, and the last one I got 9 minus 24b plus another 16b squared. So when I add up all of the areas, 16 plus 1 plus 9 turns out to be 26 minus 60b plus 32b squared. So going back to our good old-fashioned parabola, whenever you want to get the vertex of a parabola to the minimum or the maximum, and this time it will be a minimum because the parabola is going up, you do negative b over 2a, different b. So we got 60 divided by 2 times 32, which is 60 over 64, or 30 over 32, or 15 over 16. So I believe that this is the slope that is going to make the best least square equation line. So we got our point of 711 and our slope of 15 over 16. So y hat minus 11 equals 15 over 16 times x minus 7. So y hat minus 11 equals 15 over 16x minus 6.525. So when I add 11 to both sides, I'm going to get y hat equals 4.4375 plus 0.9375x. Alright, upon checking my answers, I realized that this should have been negative 56. And so when we put down 56 over 64, then the slope becomes 7 over 8. And then 7 over 8, 6.125. This becomes 4.875 plus 0.875x. So I'm sorry, and that's why we do math with pencils and not markers. Just to clear this up, y hat is always equal to a plus bx. It goes through x bar comma y bar. In order to get the slope, another way you can do it is you got r times s of y over s of x. Now we figured out how to find r before, so we could do it that way. We could do the least squares regression line, or what we normally do, which is use our calculator in case we have the points. So if we have a problem where they give us information, we know that there's a point at 3, 2, and we know that the slope is equal to 0.6 times 5 over 2.3, which turns out to be approximately 1.3. So y minus 2 equals 1.3 times x minus 3. Y minus 2 would equal 1.3x minus 3.9. And when I add 2 to both sides, we would get y equals negative 1.9 plus 1.3x. And of course, I'm going to put the predictor hats over all of the y's. Sorry for the small mistake in the one problem, but that's going to be it for this lesson.